Hi everyone, we're going to solve right triangles. So you could say that a triangle consists of 6 parts, 3 angles. For a right triangle, one of them is a right angle, and 2 complementary angles that add up to 90 degrees. And also 3 side lengths, which we could label little a, little b, and little c for the hypotenuse. When we solve a right triangle, we're given some of these parts and we have to find all the others. In a word problem, you might just want to find one of these parts in the end. Now, what will relate these various parts? Well, we have 3 tools that we can use. What relates the 3 side lengths of a right triangle, A, B, and C? Well, a squared plus b squared equals c squared. That's Pythagorean theorem. That relates the side lengths. The Pythagorean theorem. What relates the angles? Well, the interior angles for any triangle, not just a right triangle, must add up to 180 degrees. So that's a rule for the angles. And what will relate side lengths and angle measures, sides and angles? SOHCAHTOA. For example, sine of theta is opposite over hypotenuse, and so forth. That relates angles and sides. So this 180-degree sum rule for angles, the Pythagorean theorem for the side lengths, and SOHCAHTOA, which relates angles and side lengths, these are 3 key categories of tools that we're going to use. For example, let's solve the triangle below. I'm giving you that we have a right angle here. This leg is 7 feet, and the hypotenuse is 9 feet. And by the way, this is the conventional way to label a right triangle. Capital A and capital B represent the acute angles, or their measures. Angle C is the right angle. And then the side lengths are labeled little a, little b, and little c. The side with length little a faces or is opposite to angle big A, and so forth. Little b is opposite to big B, little c is opposite to big C, the right angle. So little c is the hypotenuse. This is a conventional way of labeling a right triangle. By the way, convert units as necessary. If, for example, I had given you 84 inches for the length of A, you may want to convert to feet. You'd have to make the units consistent. All right. Now, first of all, I'm giving you the right angle here and 2 side lengths. Now, what's missing? What do we need to find? We need to find the length of little b, and we need to find the measures of angle A and angle big B. I'll double circle these. We need these 2 angles and this side length. Okay. Now, again, given these 2 side lengths, how can we find this missing side length on a right triangle? The Pythagorean theorem. A squared plus b squared equals c squared. I'll do the calculations over here. All right, a squared plus b squared equals c squared. So, and these are consistent units, feet. 7 squared plus b squared equals 9 squared. 40. And now, bear in mind, the b or b squared is buried in there. Don't engage in wishful thinking and isolate b squared immediately. You'll probably make a mistake that way. The b squared is buried in there. Let's isolate the b squared. We do that by subtracting the 49 from both sides. Remember, 7 squared is 49, and 9 squared is 81. 49 plus b squared equals 81. Let's subtract 49 from both sides. B squared equals 81 minus 49 is 32. Square root method, b equals plus or minus the square root of 32. But because we have here a right triangle, we have no funky things going on with quadrants, we take the positive length. So we take b equals positive root 32. Let's simplify that. The largest square that divides 32 nicely, the largest perfect square, is 16, and the 16 pops out as a 4. Root 32 is root 16 times root 2. Root 16 is 4. So b is exactly 4 times the square root of 2 in feet. All right. So b will be 4 root 2 in feet. 4 root 2, by the way, if you approximate this on a calculator, well, root 2 is about 1.4, so I know that this will be about 5.6 feet. All right. Now, we now have all 3 side lengths for this right triangle, and we know that big C is a right angle. How can we find these 2 other complementary angle measures? For example, what if we want the measure for angle A? Well, let's see now. At the beginning, I was given that the opposite side was 7 feet. That's the opposite side relative to angle A. And the hypotenuse for the triangle was 9 feet. At this point, I could even use the fact that the adjacent side is 4 root 2 feet, but we might want to avoid that, especially if you're rounding off. So what trig function will relate an angle, the opposite side, and the hypotenuse? That sounds like the sine function. Sine of A equals opposite over hypotenuse, 7 feet over 9 feet, or just 7/9. Sine of A equals 7/9, and I know that A has to be an acute angle. So A itself has to be the inverse sine of 7/9. I'm sure we'll want to round that off. In degrees, it's about 51 degrees. And for these applied problems, when we're solving a right triangle, for example, we tend to use degrees. A is about 51 degrees. It's the acute angle whose sine value is 7/9. So this here is going to be about 51 degrees. Now for angle B, we could use SOHCAHTOA again, but let's do something even easier. Remember, the 2 acute angles of a right triangle are complementary. We're basically using the 180 rule for triangles in general. 90 degrees will be taken up by angle C. So angle A and angle B have to add up to 90 degrees. They're complementary. So we subtract 51 degrees and 90 degrees from 180 degrees, or just subtract 51 degrees from 90 degrees. Okay. Either way, remember angle B is the complement of angle A. Either way, angle B will have measure about 39 degrees. Be careful because many students might say 49 degrees because they might think percent. It's true that 51% plus 49% is 100%, but we're thinking degrees here. 51 degrees plus 39 degrees is 90 degrees. So be careful. We want these to add up to 90 degrees, not 100 degrees. You're thinking 100% then. Okay, so this here, angle B is 39 degrees to the nearest degree. So this all makes sense. These all add up to 180 degrees. The interior angles all add up to 180 degrees. And check this out. The eating rule checks out. I call this the eating rule. The idea being that larger angles eat or face longer sides. The largest angle here is the right angle, 90 degrees. The right angle must be the largest angle in a triangle. It faces the hypotenuse, the longest side, 9 feet. The medium angle here is 51 degrees. It faces the medium side, 7 feet. The smallest angle, 39 degrees, faces the shortest side, which turns out to be about 5.6 feet. If you had gotten something like 10 feet or 56 feet, you know you made a mistake. Also, there is something called the triangle inequality. which basically says that a detour cannot be shorter than a straight length. So for example, 9 feet has to be shorter than 7 feet plus 5.6 feet, because this represents the straight line segment distance. The detour here must be longer. So you must satisfy the triangle inequality. So again, this could not be 56 feet. So if you accidentally put the decimal point over here, you know this cannot be 56 feet, because 9 feet plus 7 feet gives you a shorter detour, 16 feet. That cannot happen. So these are some basic checks. They're not necessary, but they're basic checks just to make sure that your answer makes common sense. It's good to check to make sure your answer makes common sense. So we've solved this right triangle. We now have all 3 angle measures and all 3 side lengths. Part C is optional. These are other ways that you can measure angles or directions. So for example, if you're going in this direction, you might say that a boat, say, is going 30 degrees east of north. So this ray here makes a 30-degree angle with due north. Again, that will not be on the homework or exams. In air navigation, you might take due north as 0 degrees and measure clockwise. So this southeasterly direction may correspond to, say, 150 degrees clockwise from due north. But again, Part C will not be on homework or exams. And that is Chapter 4.